Hey YouTube, welcome back. Today we're talking about CAP theorem. So in the world of distributed system, you can't have it all. CAP theorem says that you have to choose wisely or you will face consequences. So let's dive into this core concept and shapes models that shapes every distributed systems and that shapes model text. So why this matter? So, scaling across regions, building reliable apps, designing cloud services, all hinge on understanding the CAP theorem. It's not just a theory; it's what decides if your it's what decides if your app survive outages, partitions, and even disasters. So, what is a CAP theorem? CAP theorem stands for let's focus on the CAP first. The CAP stands for consistency, availability, and partition tolerance. And it's the theorem says that in the event of a network partition, you only can choose two of these three things. Think of it like balancing three spinning plates. But if one falls, which is a network break, you can save only two. So you cannot have all three in your system. You only have two. Okay, let's just try to think about what is the consistency, availability, and partition tolerance. So let's just give it a deep dive. So first, what is consistency? Consistency means all nodes see the same data at the same time. You update your account balance every server, or you update your account balance, for example, for your bank account, and every server will agree instantly. Okay, what is availability? Availability means that availability ensures that like every request gets a response, even during issues. Data may stale, but you get response anyway, and you will not face any error. An example for that, maybe for example, you using like social media application. Next, we have partition tolerance. A partition tolerance means that your system will keeps working even if part of it can't talk or if you have a network partition. Network fail all the time, and true distributed systems must survive it. So I would say partition tolerance it's not something that you can avoid. So you find yourself most of the time you're choosing between a CP system, which is you guarantee consistency and availability, and an AB system, which is you guarantee availability and partition tolerance. Yeah, sorry, so not consistency, availability, consistency, partition tolerance, and availability and partition tolerance. Okay, let's try to think that because you cannot have all three, you can only have two. So first we have a CB system. This one, a CB system. Okay, and a CB system. This when partitions happen, you sacrifice availability for strong consistency. Some users will request. Some user requests may be denied for that. An example may be using like a relational database or maybe a bank account. Next, we have an AB system, which basically you always give a response, even if different nodes show different data temporarily. An example for that may be DynamoDB on Amazon or any social media application. Next and lastly, we have a CA system, which is consistency and availability. This one only works without partitions, particularly impossible in large distributed systems. You can think of that an example. Maybe you have a single node, which is like a local database, something like that. Okay, we need to talk about some practical strategies to navigate the CAP theorem. The first thing we will talk about like eventual consistency. It's useful when perfect synchronization isn't critical, like social media timeline, for example, DNS servers and some CDNs use this. Next, we have strong consistency. Required for financial transactions, sensitive system. Example for that, like bank transfer and any health system, basically. 3, tunable consistency. Some database let you pick consistency level per query, like Cassandra, I guess, do that. And we have a quorum system. Basically, this means majority voting will ensures agreement before committing the data. It's core of Raft and Paxos protocols, I guess. Okay, let's talk about some real-world examples. So first, we talk about Amazon DynamoDB, which is it's an A/B system. So basically, it prioritizes availability plus partition tolerance. Number 2, we have Google Spanner. It's a CP system, which basically pushes for strong consistency plus partition tolerance. We have Netflix architecture, which is prioritize availability first and accepts inconsistency, so it is A/B system. Okay, let's make a recap and talk about some interviews tips. So in interviews, when asked how would you handle partition failures, we need to talk about first which property you prioritize, 2, why, 3, how eventual consistency or quorum helps. You need to show trade-off of thinking, not just textbook definitions. It's pretty important to think about that. So yeah, CAP forces harder choices, but understanding it make you a better engineer, and you need to choose based on your app's user, not just tech. And yeah, that's it for this video.